Okay, welcome back students. We're doing question 8 of the 2023 paper. Now I just want to bring something to your attention here in terms of how many marks questions are worth that you're not told during the exam. So this is question 8, it's worth 30 marks, which is relatively quite a lot. We had the same for the previous question, question 7, and if you scan through all of this you see only question 2 was worth more. So there's quite a big variety in what questions can be worth, from 10 marks all the way up to 35, and you get some sort of indication for this from this here, how long to spend on them. Okay, so we might just start looking at that, and we could even turn that into a very interesting statistics question to see is there a direct correlation. But for now we know in this particular case 10 minutes is worth 30 points, and that's only retrospectively. But just do keep an eye on your time during the exam. Okay, let's get started then. Convert 7.5 kilometers to meters. Okay, this is from the number strand in your course. You need to know that a kilometer, 1 kilometer, is the equivalent to 1,000 meters. So this in a way is our conversion. So if we're replacing kilometers with meters, we have to replace the kilometer with 1,000 meters. So let's just do the calculation. 7.5 multiplied by 1,000 meters, okay, and that is 7500. Moving on, a plane P took off from an airport. It left the ground at the point T. So I see this is an application of right angle trigonometry. After a few minutes it was 7.5 kilometers from T. We know that in meters as well. So here we're already seeing we have a mixed units, so that won't do. We'll have to change them. We'll have to change one or the other. They've already kind of suggested we would be putting this in meters, or we can, because we've already done that conversion. So that was nice. Use trigonometry to work out the size. Now the reason they didn't do that to scale is it would be a very skinny. You might be quite surprised at how small the angle of elevation is, even when you're taking off in an airplane. Use trigonometry to work out the size of the angle marked E. Okay, so this is a sine, cos, or tan question. The two lengths that we know are meeting up here. There's a right angle, there's a reference angle that we're trying to get, and then there's the other angle. So it's going to be sine. I'm going to show you how you work that out now in the trigonometry page. So you go to your tables and you look up trigonometry, and you see it somewhere around page 13. It's a very long section, so just because it starts on page 13, we end up going to page 16 for the sine, cos, and tan ratio functions. So what we can do here is we can compare the right angle that appears on page 16 with this right angle here, and we can see that we're using like for like. We're having C and A known. Okay, now if we look at which formula uses C and A, we see that it's sine. Okay, so we can write that the sine of E, and we can replace A and C with 200 and 7500. Okay, so we know what the sine is, but the thing is they're going to ask us to find the angle. So what we do here is we do inverse sine to both sides. So the way you've been learning in class is to leave a space. Now inverse sine both sides, which basically means that sine goes away from there, and the way you write inverse sine is this. So this becomes our calculation for E, which we can do on a calculator. Okay, so what we want is to use the function inverse sine, which sits behind sine. To get it, you hit shift, inverse sine. fraction bar 200 over 7500. Because this is a compound calculation, you want to close your bracket there. Okay, now sometimes you get a very small answer and it's because your calculator has been in radians, not degrees. That's not the case here. I told you already that we will be surprised with how small the angle is during the climb. It's just 1.5 degrees. Your ears can pop and pressure can change and it can feel very steep, but that is a realistic number for this situation. Give your answer in degrees, correct to 1 decimal place. Well, I'm glad they didn't say correct to the nearest degree, because it would be quite different relatively. Okay, so the answer is 1.5 to 1.5 degrees to 1 decimal place. Okay, that's a long question. We better move on. We've a lot to do. Write 20 minutes as a fraction of an hour and give your answer in simplest form. So 20 minutes equals 1/3 of an hour. If we can do that by inspection, that's great. Yeah, done. During part, so we just say why that is the case. 1 hour equals 60 minutes. So the question is, what's 20 over 60? And it's equal to 1/3. Excuse me. During part of its flight, plane P traveled 598 kilometers in 2 hours. So this looks like a distance speed question. So speed equals distance over time. If you want to use the triangle for that, that's fine. We just make sure we write down a formula as well that you're going to use, because they can take marks off because the triangle isn't really a formula. Distance, speed, time. It doesn't have an equals in it. Okay, work out the average speed of the plane during that time in kilometers per hour. So speed is distance over time. We know the distance is 598 kilometers, and 2 hours. And I just want to see per hour. That's fine. So it took 2 hours and 20 minutes. Oh yeah. So 2 hours and 20 minutes. So we know that 20 minutes from up here is 1/3. So it's 2, and the best way to write that is just 0.333 reoccurring. And if you just put in a pile of 3s, it'll be accurate enough. So we'll drive on with that and go with the calculation itself. Doesn't matter what calculator you use, it's going to be the same sequence of buttons. Old or new. 598 fraction bar 2 point, as I said, if you do a load of 3s like this, in fact on this new calculator it does assume that you actually meant exactly 1/3, and then if you do shift equals it to bring it to decimal. Okay, and that'll be 256.2857 ... And what's happening next is we're looking at what do they really want to give your answer correct to 1 decimal place. So the 8 in the 2nd decimal place will mean that 2 gets rounded up. So 256.3 kilometers per hour. Okay, as I said, it's going to be a long question. Let's see how we're doing so far. So let's see with this one first. We got 1.5 degrees and we got 7500. It's a bit lazy there on the meters. Oh no, I wasn't added in there, and they'd included it. Great. And on this one, we got 1/3 of an hour. Again, it's written there. 256.3 kilometers per hour, and there's alternative ways of doing it, as there always is. That's fine. We're getting on great so far. So the next part of the question is here. So let's read it carefully. In the diagram below, each of the points A, B, and C represent an airport. Great. The plane travelled 598 kilometers from airport and then travelled to airport C. And there's some measurements in here and so on. Work out the distance A to C. Correct to the nearest kilometre. So I'm looking at that there and I'm thinking, well, let's work out this distance. Let's call it X. Now the marking scheme, the model answer might call it something else. And let's work out this distance. And because this is a right angle and this is straight across, we're just going to add those values. So let's get X using Pythagoras. X equals, now we're getting the shorter side, so we're using minus in Pythagoras. So we're getting 598 squared minus, oh, I have to be careful here, do I? No, 280 squared. And I want to be fair to you now and show you back to page 16 that this is Pythagoras, okay, which says that you can work out you know, any side from any other two sides. Okay, so the way this is being used here is that we know that a squared equals c squared minus b squared, where c is the hypotenuse, and then if you take the square root of that, you're getting this, you see, you're getting the long side squared minus the short side squared. So this is a very direct method to get the answer. Let's use the older calculator here. So we'll go, but not that it matters. Be the same on any of the calculators. 598 squared minus 280 squared, and shift equals to go to decimal. I don't think we actually need it here to go to decimal anyway, so it equals, because it's irrational, 528.397 ... I always write down a good few significant figures before I go worrying about rounding, okay, especially where we're going to add this to y. So let's look at y now. In the case of y, we only have one length, not two, so we cannot use Pythagoras. We can use sine, cos and tan to figure out which one. You find where those two meet, whereas the included angle is their right angle, so it's tan. And I'll show you that carefully with this as well. We're thinking that we know the 280 here. We don't know y. Okay, it's flipped over going the wrong way, but it's as if this is y and this is 280. And when you're using a and b, you see you're using tan. So we start off by writing down the tan of 35 degrees equals 280 over y. And then we need to, now we're going into, that was trigonometry from page 16. Now we're going to use algebra to isolate y. Y is, unfortunately, it's part of a proportion and it's on the bottom. So we're going to take this factor and multiply it up. And similarly, we're going to take that factor that we don't want and multiply it down. So you get y equals 280, stays where it is. So y comes up, the tan goes down, tan 35 degrees. Okay, which goes in your calculator. 280 fraction bar tan 35, close your bracket. You see that? Very, very important that that's a D. We get 399.88. Correct to the nearest kilometre, that's 400 kilometers. And correct to the nearest kilometre here, that's 528. We're going to add them together, which we can do with mental maths, and that's 928 kilometers. Okay, does it look like it makes sense? Yeah. Let's see how we're doing. Where's my marking scheme? Here it is here. I need to get D. Not there, I'm going to that. Let's see where we're at. I want to compare our answer here with question 8D. So we're getting in total 928. They got the same here. They used Pythagoras to get 528. That was their only option anyway. They used the tan function to get this. The only difference I would say is instead of calling that a, they probably introduced a d in the middle, label as d the point at the foot, and then they use geometry names, but there's no difference, and the x and the y is probably a bit easier. Okay, got that out, and hopefully that's the end. Yeah, that's the end of question D, and as I said to you, it's going to be a long one, but you do have some long questions in the exam, and you just keep going and don't think it needs to be over quickly. You'll do some questions very quickly, and other questions there'll be a lot more problem solving. Stick with it, persevere, you'll get there. Okay, as always students, we'll see you in the next one.